Okay, how are you? Good. Welcome to my course, Plant Science 475, 575, and also close listed with ABE, Ag Biosystem Engineering. So some of you are taking Ag Engineering course, and some of you may be taking Plant Sciences course. And I have, in my record, total of 32 students, including undergraduate and graduate level. More undergraduate students than graduate students. And then about the same number right now between the in-class students, which are you guys, and online students. There are, UMA students, and then also campus students. Okay, you are in the right course. All right, so how was your first day of the semester? First class. Oh, you came for this one. Great. Thank you. Let me introduce myself. I'm Chieri Kubota. I'm just adjusting microphone level. I'm Chieri Kubota. I'm a faculty member in plant sciences, and I have a joint appointment with agriculture biosystems engineering because I'm a sort of hybrid between plant sciences and engineering. I'm familiar with both areas. So my expertise is a plant physiology in controlled environment agriculture. So it's applied plant physiology. So you probably, some of you probably learned plant physiology undergraduate level. Lot of information, right? So my course, you learn additional, whole plant canopy, many plants growing together, ecophysiology information. And then the uniqueness of this course is you are going to learn how to apply that understanding of plant physiology in the real world food production, plant production settings. So that's the big difference between my course and some other plant physiology courses. Okay, we call that applied plant physiology. All right, and then some of the students get overwhelmed because the amount of information we have to go through, particularly during the first 1/3 of the course, a lot of information. But toward the end, all the information sort of come together, then you can exercise that understanding to understand what's going on in crop production under controlled environment. Some of the information is very relevant to open field production systems too. Okay, just because open field you don't have means to control climate, so you don't exercise that. But understanding of how plants respond to specific environment, light, temperature, movement of air around the plants, it's very, very important. And that's what you learn in this course. This is a really, really good course. And you get constructed understanding of plant physiology under controlled environment. And then my course also covers some of the engineering type of contents. So for plant science students, I don't know how many of you are plant sciences, non-engineering students. Okay, so for you guys, once in a while you might feel overwhelmed because some of the concepts I use, sort of engineering oriented, but I try not to intimidate you because, for example, mathematical equations or concepts of engineering basically help you to understand logically, what's the input, what's the output, what's affecting and how sensitive to those factors. So that's what you learn. So not so much memorizing in my course, okay? Because I don't like the just pure memorization. I like you to understand so that you can exercise the understanding. So that's my goal. All right. Yeah. So I'm a faculty member, right? And then I grew up in Tokyo. So I'm an international person. Came to U.S. first time in I think 1994 when I was a graduate student. Wanted to participate in a conference, horticulture science conference, and wanted to meet people and present my paper. So that was the first time I came in this country, just for a short period of time. But I had multiple opportunities after that, working as a researcher at the beginning, and then as an exchange scholar, and then now as a faculty member. So because I grew up in a non-English environment, some of the pronunciations, you probably already picked, but if you have an issue, please let me know. And then certain sound, I'd never be able to do that. It's no way for me to do, and I have to admit that. But if you feel, I'm happy to repeat or write down, so that, because you need to understand, because you are here to understand. And this is my responsibility to make sure you're understanding. Okay? Any questions so far? All right, so today's lecture is basically introduction. So I'm going to go through the introduction of the controlled environment agriculture, mainly in the US. What's the status? So it's not much physiology in this lecture. So sort of, you can sit back and relax. And then at the end, I like to go through the structure of the course and some of the information you want to make sure so that you wouldn't miss. I like you to read the syllabus. Okay, so that's very important. But I will pick up some of the key information from the syllabus so you wouldn't miss. All right, and I usually print out my slides so that you can actually put the notes in there. That might be helpful. And the 2-slide version, color, is already in the D2L website. So when you go to D2L under the content, every week we have a module. And under each module, you can find the copy of the lecture slides, 2 slides in 1 page. And you can find a link to the podcast video. And then you can find a separate Panopto link. You know Panopto? Yeah. So that is, you can easily navigate, where to start or where to review. So if you haven't done that, you might find that it's more useful than podcasting. Good thing of podcasting version is you can download the entire video to your iPad or whatever computer, and you can watch my lecture offline, right? So that's big difference. Some of you might want to do that because then you can actually fast forward quickly. Some of the things I might go too slow for you, then you might want to just fast forward, and I would be speaking really fast. So that's how you want to use. And then reading materials and homework and everything is online. Okay. Okay, I think yeah, so any questions regarding the materials? Did you find my course website already, the D2L site? Okay, good. If you have any questions, let me know. And then I'm more than happy to get your feedback, regarding how the contents should be structured, so that easier for you to navigate the course website. Okay. All right. So, introduction. Okay, the first lecture. How do I? Maybe this. Okay, so you are sitting in CEAC. How many of you actually came here today as the first time visiting CEAC? You have been here before? Oh, good, great, wonderful. All right. So you probably know, those faculty members in addition to myself, Jin Giacometti, engineer, Pat Roraber, plant scientist, and Muraka Chira, engineer, working together for promoting this technology and doing education and research and outreach. And then my charge is mostly for research. So my research is, basically science-based technology development. And then I utilize my understanding of plant physiology a lot. So you get to know some of the projects I'm doing because this is an upper level, undergraduate, and graduate level course. So I like to show the most, updated information of research as well. So that's what I do. The center, this is the CEAC, is one of the kind. You probably don't find centers similar to this in the U.S. So you're lucky you have this at University of Arizona, or we are lucky we have this at University of Arizona. The uniqueness is, again, engineers and plant scientists working together. Okay, you don't see that much outside. So if you are familiar with agriculture in the U.S., it's pretty much open field production. Okay, majority or most of the produce are coming out of the field, not from the greenhouse. How many of you actually worked in a greenhouse? All right. Oh, excellent. Majority of you. All right. Yeah, so it's a rare experience. Not many have that experience in the U.S. So those pictures are, you see, oh, let's show that. So the open field melon production in west of Phoenix area. And then this is a Florida, I think, pepper production. Yeah, green pepper production. And then this is a Yuma area, baby spinach production. And then this is California strawberry production. So there are lots of, different kinds of produce coming out from the field. And then if you look at the map like this is a map showing the lettuce production in the U.S. The size of lettuce is basically representing the amount of lettuce produced in that particular state. So if you look at this kind of chart, you see our produce are pretty much coming from limited number of states. All right, California always #1, right? Lettuce production, and then wintertime, exactly during time now, you see lettuce production in Yuma, Arizona. So the Yuma is probably 25% to 30% lettuce production annually, but mostly concentrating in the winter time. You probably know that, right? Strawberry production the same way, depicted. California 90%, and then very small amount in Florida, and then almost ignorable, negligible amount of production going in North Carolina, Oregon, and Washington. And then Arizona used to have good strawberry production, but not anymore. It's just disappeared. Oh, there's one. That's right. There's one grower doing strawberry production in a field in Yuma area. So that's the only thing I know, unfortunately. Fresh tomato production is more distributed, but still, concentrated in certain areas. And so those yellow circles are sort of the production is added to the USDA data because USDA doesn't report Arizona and Texas data because only a few number of large companies presenting. So it's just disclosure of the specific company's information. So that's why you need to add that thing. But anyway, so those two states are basically doing hydroponics greenhouse tomato production. And some of the California fresh tomato are grown by hydroponics, but not majority. It's not large. And most of the Florida is open field. And then some of the other states, probably high tonals or a greenhouse, but the percentage is, again, very small. So controlled environment agriculture, the great thing is high yield you can achieve. In tomato, we know you can get as great as 20 times yield per year compared to open field. Okay, that's amazing number. And then also high quality. You know, the quality of the produce is excellent. Therefore, supermarkets want greenhouse tomatoes rather than open field tomato because the visual quality is very important for marketing. So that's why you see the number, but controlled environment agriculture area is increasing rapidly over time. And controlled environment agriculture can minimize resource usage, such as water, pesticide, and fertilizer. Okay, you don't waste too much, like you might see in open field. And then the very important thing, year-round production is possible, in controlled environment agriculture. And to do that, to get the high yield, high quality, and year-round production, there are multiple technologies available, high-end to low-end. Okay. So I'll show you some of the pictures in later. So this is a sort of a table or chart showing what system or locations can produce when in the year. So that's the harvest month. So from January to December. In greenhouse, lettuce production can be year-round. Open field, as I said, California. Many places can produce, and longest one is I think this is the Salinas Valley, and it's the southern coastal California. And then Arizona, which is Yuma, basically, is in winter production. So none of the places can produce year-round. Even Salinas, it gets too cold in winter, therefore it has to go to Arizona to produce. But greenhouse does. But if you look at the production area, it's very small, 23 or 24,000 hectare. If you're not familiar with hectare, 2.5 acres equal 1 hectare, or 1 acre equal 0.4 hectare. All right. One of the things you learn is I use SI unit, scientific unit, rather than British English unit. Okay. So that's you will be learning more next week. 0.4 hectare. 2.5 acres, 1 hectare. Make sense? Okay. All right. So yeah, so if you want to convert to acreage, then that's what you want to use. Okay, so the same thing, same kind of information for tomato. Again, greenhouse, U.S. greenhouse particularly, and also Mexico, Baja California, can do year-round production of tomato. But in the field, you have to combine, California, Florida, Mexico to supply, and then also Canada to supply year-round. You expect tomatoes sitting in a grocery store all year round, but those are coming from everywhere, right? And then you don't know where exactly, right? You may see the product of Mexico, a product of U.S., but where exactly in the U.S. usually doesn't say. Greenhouse product usually have the name of the company, so you can see where exactly they are from. Again, greenhouse is very small in terms of area, not much, but it's increasing. Right. I'm going to show you some of the pictures from here. So this is I guess I would say newest greenhouse in Arizona. It's in Amado, Arizona. So it's about 1 hour driving from here toward Nogales. Right, there is a nice facility there doing organic hydroponic growing tomato using a high-tech. So the structure and controlled environment systems are super high-tech. but the production method, particularly the fertilization, substrate, and pest management, those are organic. So it's a quite interesting, unique combination, right? Okay, so the high-tech version of low-tech. So that's what I would say. All right, and then this is probably 15 years now, or maybe more, doing a lot of production of tomato in Wilcox area. That's a picture, glass greenhouse. Many high-tech greenhouses are using glass glazing, the covering material, because it transmits more light and easy to control climate. And then you will learn that, why. One of the lectures I cover. It's a very impressive facility. Plants also grown, the seedlings, transplants, the starting materials also grown under controlled environment. This is a Canadian greenhouse. It's in British Columbia. And then those plants actually grown there, but shipped to Arizona, Texas, Mexico. Okay, long distance transportation. It's kind of amazing. Plants travel so many miles over multiple years in refrigerated trailers. So that's quite interesting. So the greenhouse is used from seeding all the way to the harvest. This is a snapshot of the greenhouse. I think it's in Wilcox, Arizona, producing massive amount of tomato in a system we called high wire. High wire system, yeah, so that picture is also showing the same company's production system. So the high wire system is developed in the Netherlands, Holland. Dutch people figured out how to maximize the productivity of the plants based on the understanding on plant physiology and phenotypes of the plants based on the genotype. So plants can grow forever as long as the good amount of nutrient and water and maintenance are provided. But they terminate the crop usually up to, after 1 year of production, because after that it's not gonna be economically productive. So that's why. But instead of growing tomato plants in a bushy structure, right, like you might see in California processing tomato, those plants are just single stem, okay, at most 2 stems from one root system, and then growing into 10, 15 meters, okay? It's a long vine. But maintaining the canopy in a zone, you can actually control very well in terms of temperature, humidity, CO2, air movement. So that's what they do. So that's why they can grow such a large number of, they can produce a large number of fruits. All right. Low-tech version, high tonals, this is a minimum controlled environment, all right? Just covering up and then maintaining temperature a little bit, protecting from rain and maybe wind. So that is actually exercised a lot all over the country. Those pictures are from California. And let's lower a little bit so that you can see. Yeah, so you might see about 1,000 acres or 400 hectares in California state only. Raspberry and berry productions. It's a massive amount of production going right now. It's amazing to see that. This is a low-tech version of seedling production. I think the picture was taken in Yuma. So the Yuma, there are so many vegetable growers, and then the plants are grown in a low-tech version greenhouse provided to the open field producers. I bet the plants are pepper plants showing in here. All right. And this shows increase of greenhouse area. It's very much, exponential growth, a total greenhouse area in North America. But the big contributor is Mexico. Huge number of greenhouses and acreage over there. So if you look at the statistics like that, this is a USDA tomato statistics. Up to 2000, there was no category like greenhouse tomato. But because of the increase, as you see in the previous slide, suddenly they have to separate greenhouse tomatoes from other greenhouse categories. So the statistics start in year 2000, and then up to 2009, I got this data. It's almost linear increase of greenhouse tomato. So that massive amount of tomato is coming from Mexico for the markets in US, right? And this is the list of areas, acreage, or the hectares of greenhouse in different countries. So that China has insane, number of hectares, 2.7 million hectares times 2.5 is acres, right? And then followed by Korea, Japan, those Asian countries. Actually, Korea, Spain, Japan, those countries, using greenhouse as a production means to produce varieties of crops. US is not too bad, number 11, not in the top 10, but number 11. But if you look at really closely what's in there, the big difference is what is the greenhouse used for. So this one is a two-country comparison. Because I'm familiar with Japanese statistics and easy for me to find it. So just comparing, so the greenhouse rich or oriented production country, and then the US. So the base number is very different, all right? So this is 67 or 68,000 hectares, and US is only 8,000. But the point I want to make here is, see, Japan has 73% vegetables. So that out of the total area of greenhouses, 73% of that areas are used for vegetable production, okay? US, where's vegetables? It doesn't show in here. It's in others. So it's less than 10%, maybe a 5% maybe. Much of the greenhouses we have in the US are used for bedding plants, ornamental plants, the floriculture plants, okay? All right, very different, right? So greenhouse in US, pretty much like that. When you pick a greenhouse, you probably see ornamental plants growing, not the vegetables, because that's small percentage. So there's a huge potential, all right? That's why it's increasing right now. And then also, if you look at what are grown in the greenhouse, vegetable greenhouse is also different. Japan and US comparison again. Japan on your right-hand side, so varieties of crops grown. And US pretty much tomato right now. 70% tomato, cucumber, herbs 7% or 6%, and lettuce only 3%, and strawberry 1%. So it's very, very dominated right now, tomato. So there is more opportunity, I would say, in US. Again, the base number is very different. Nearly 900 hectares in US and much, much bigger number in Japan. And one of the interesting difference I found, okay, is if you look at the 900 hectares of that production, 90% or so are basically hydroponics. Okay, but in Japan and other countries like Japan, Spain, and Korea, and China, hydroponics are very, very small percentage. Most of them are using soil-based production system. So it's quite interesting. So something we may want to develop is developing hydroponics further, because that's the strength of United States, the vegetable production under controlled environment. And then also maybe, increase the soil-based, a little bit medium, low-tech type of applications too. Because obviously those countries are doing soil-based controlled environment because of low cost, right, of the structure, and advantage over open field production system. All right, if you look at the greenhouse locations, this is a distribution. I separated for vegetables and floriculture. because there is a big difference in terms of trend. So the vegetable greenhouses, it's a very small number, right? Only 900 hectare or something. Pretty much in California, Arizona, Texas, 3 states, right? Southwestern United States. The reason is that vegetables need more light, and those states have, particularly Southern California and the desert Southwest, we have a lot of light in winter, and that's the advantage here. We can, be successful in controlled environment agriculture. You will learn a lot of light environment during the first several weeks, and then again after, I believe after a midterm exam, right? And then you get a whole package of understanding of light environment in a plant production system. If you look at the floriculture ornamental, up to recently, it's basically distributed all over the states. Maybe because the products are perishable, so you can't ship from California easily to East Coast, like mums and flowering plants. But things are changing right now. So it's kind of, they are trying to consolidate. So the large company dominating and then supplying all the, the products to all the big chains, box chain retails. So that's going on right now. So it might be a little different look in few years now, but that's the current or the relatively recent data. So it's additional information, but so those greenhouses distributed nationwide and doing traditionally floriculture ornamental plant production started losing the market because consolidation going on in California and other big states, maybe in Florida. So they are seeking opportunities, instead of looking at and then continuously growing flowering crops, they want to shift to vegetable crops and then supply vegetables to local market. So that's what they are trying to do, and that's why we see more, greenhouses doing vegetable production nowadays. Okay, the largest company in Arizona, 127 hectare. I just wanted to give a perspective. Located in the traditional, open crop field. If you do a Google map, you can find the greenhouse, but it's amazing amount of greenhouse under the glass. Second largest one is in Texas. I think distributed in 2 or 3 locations in Texas, but the total hectare is 100 hectare. That is quite large. California, there is the number 3, the largest, the 3rd largest company there. So as you can see here, many of them are very big company. And then the 3rd one in California. And California situation is quite unique because it's very close to urbanization. It's a suburban area to Los Angeles. So situation is slightly different from what we have or in Texas. So this particular company is more interested in using sustainable technologies, renewable energy, using a solar panel to generate electricity, using a cogeneration to generate the power, and in addition to generating electricity, they generate hot water and then also CO2 to inject into the greenhouse. All right, and this is what we call semi-closed greenhouse. This is a high-tech in greenhouse we see, and then I will have opportunity to talk more about this in one of the lectures. All right, and then there are small growers too. This is a family-operated greenhouse in Arizona. Very nice greenhouse, growing microgreens and baby greens, providing to local supermarkets and so on, farmers market. And in those companies, small farmers also paying attention to sustainable technologies such as renewable energy. This company is using pelletized pecan shells. Nobody uses pecan shells, but they can pelletize that and then use that as a fuel to heat and they increase the temperature at night in Arizona. And then also they pelletize tomato vines, I believe. Yeah, tomato vines to be used as additional fertilizer. So the vegetable-based fertilizer. So that's also innovation coming up from those small controlled environment agriculture growers. So let's see a few pictures of Mexico. This is from Sonora, Mexico. In Mexico, a huge range of technologies, high-tech and low-tech. This is a high-tech greenhouse in Sonora, so the southern Mexico. No, the other way, northern Mexico. And then you see the equivalent technology as you might see in US or Canada already there. But majority of them are still soil-based, like this picture to your upper right. This is a bell pepper production facility. I believe it's in Sonora also. And the left-hand side is a strawberry. This is not exactly soil-based, even though the ground is in soil, right? Not covered with concrete. But they are using substrates, horticultural substrates to grow strawberry. And they are organic strawberry production facility. And in Mexico is, the product in greenhouse is more diversified. So US is pretty much tomato, and Mexico is too, but you can see more different crops grown in Mexico. And this is Baja California. It's also impressive, the low-tech, the greenhouse. It's not like Nature Suite or other companies. It's not the high-tech, but the low-tech in terms of controlled environment facilities, but amount of area covered with plastic material is huge. So underneath, they have tomatoes, tomato plants growing.
Do you know
Which
which city is that?
city? San Quintin? Yeah. Are you from Mexico?
Yeah.
Do you know this area?
Yes.
So this is the largest, I was told. This is the largest company in Mexico, tomato producer.
Yeah, they're pretty big.
Yeah. Okay. Yeah, okay. And then high-tech is used for cleaning water. Their groundwater was pretty much high salt. I think the prolonged production of tomato in ground increased the salinity of the groundwater, and no longer, is acceptable level to grow crops. So they have to basically purify the water using RO system, and then mix the RO water with the groundwater, so that reducing the total salinity level to the acceptable for the crop. It's very expensive, so they can't use 100% RO water. So they are mixing, I don't know, I forgot the ratio, but certain percentage to reduce the salinity. So it's just amazing, things like that happening very close to us. Okay, all right, high-tech, high-tech. This is an old picture, probably 1991. It's in Holland. They are producing rose cuttings, so the rooted cuttings, so the planting materials under multi-shelves environment. And then now you can see similar one, but all LEDs. One before was white fluorescent tubes like those over there. Or in the office, the white fluorescent tubes was the old technology. And now LED, light emitting diode, is new technology. And you see this purple, purple growing environment everywhere. You might have seen that in the newsletter or the news. Why purple? That's what you are going to learn, but red and blue mixed. And then that's why purple looking. Plants are not liking purple. Purple itself is a much lower wavelength, but red and blue make it look like purple. But actually the components are red, mostly red, and a little bit of blue. But anyway, so that's facility in Holland, the Netherlands, growing lettuce seedlings inside the multi-layer system LED and growing the seedlings as quickly as possible, regardless of the weather, all right? And then those seedlings are transplanted in a greenhouse hydroponic system. So this machine or robot is transplanting the seedlings grown in a multi-layer LED system, and then those trays are going to be transported to the greenhouse to finish the rest of the production, maybe 3 weeks or 4 weeks additionally. So it's a very impressive facility. I had the opportunity to actually walk through that, the system, which was amazing. It was quite amazing. All right. This is a small company, but in Arizona. This company is doing also seedling production in artificial lighting, electric lighting, fluorescent tubes to start with, and then now shifting to LEDs. One of the graduate students, or one of the leading scientists in this company is actually U of A graduate from this program. So you will have probably in the future opportunity to be someone like him start the CEA company. But anyway, so they are growing very successfully, I guess. This is already old picture. I know they have a much bigger area to produce in sophisticated system. Okay, talking about vertical farming. It's growing quite rapidly worldwide, particularly concentrated in Asian countries and some of the European countries now. This is actually pictures from Japan. Left-hand side is a Subway sandwich restaurant in downtown Tokyo. They have a little, growing facility in the middle of the restaurant, just to, I think just to make the point, they pay attention to the growing, environment, because I don't think they can provide entire, necessary amount of lettuce for Subway sandwiches, right? So, but it's very clean. So one of the big motivations of this kind of high-tech indoor vertical farming is clean, no pathogens for human disease. So that's the big thing. And then also consistent supply. But the drawback is, as you can imagine, the high electricity cost. So that's one thing. Right-hand side is also lettuce production facility, several meters, very tall vertical production facility. Urban CEA is also increasing rapidly in the US and other countries. These are the US companies. Top one is the rooftop greenhouse in New York City. They recently announced that they are building another facility in Chicago, downtown Chicago area. So they are very successful. They have 2 facilities in New York City, one in Chicago, and one of the New York City's facilities I have been is on top of the very large high-end grocery stores. And so the produce is produced on top of the roof and then just go down through the elevator. So the food miles is basically 0, right? Or vertical, whatever. So anyway, so that's going on. And then again, U of A graduate is leading this, growing project. So, okay, and the right-hand side is Ohio near Cleveland. And there's a little area sort of depressed, low economy, crime rate, and so many issues. So they decided to build this fancy facility so that creating jobs, creating employment, creating food. And so that's one of the successful projects, using controlled environment agriculture. All right. Okay, and then this is in Michigan. It's a Green Sense Farm, Green Spirit Farms, a company who is doing vertical farming, leafy crop production using electric lighting. So it's impressive facility. I had, again, opportunity to visit, and it seems like they are very successful, very successful. So those projects are popping up, many locations in the U.S. So many of them are looking at local market, fresh produce, rather than, you see the chart of, much of them are produced right now in California and shipped all over the U.S. Instead of doing that, producing high quality lettuce and leafy crop, nearby, and then creating it's a high-end market, but it's creating that kind of application. Right, so in my course, you will learn varieties of applications of controlled environment, and some of them I mentioned in the presentation up to here. And then there are other applications of controlled environment. And for those who may not be a grower or who may not be actually working in the area relevant to controlled environment, you can still see this course information very useful, particularly for those who are going into R&D in horticulture industry or plant biotech industry. This information helps you to design your experiment, or to properly, or to translate whatever you get as a result in terms of the plant response to the environment. Very unique research platform, controlled environment. It is used for research. Small compartment, and then maybe very shady because structural material is above your head. So you need to understand, even you are in a research setting, small non-production setting, you need to understand what's going on in your setting so that it helps you to operate the experiment or research. Okay, any questions so far? Okay, good. And then I'm trying to finish a little earlier than usual. You know that this course, this class is 4:15 to 5:30, right? Okay.
Are we going to go into the greenhouse during the class?
Yeah, that's why you are meeting here. Yeah. So the good thing of in-class students, we periodically go to the greenhouse for me to actually point out. So here, this is the top leaf and lower leaves and how light intensity is different, things like that. I do that because that is the most effective way for you to understand. So online students can't have that opportunities. So what I do is usually videotape. It's a little, not exactly the same, but still, they can see what we are doing while we are chatting in the greenhouse. So I usually take this iPhone with me and doing like this, and so that they can see what we are talking. So that's what I do. And then, by the way, that iPhone setting is my backup. So if anything happened and not being able to record, I'm going to use that as a backup for the lecture, because simultaneously teaching in class and online, online students are relying on that technology so that they don't miss anything. Okay, all right. Any other questions? Good. So this is something you can find in the syllabus, but basically I talk about plant responses and to environmental conditions. So my first many courses are talking about temperature, talking about light, and CO2, all that conditions, and you get a lot of information out of that. And then you will be familiar with terminology. Okay, what is photosynthetically active radiation? Can you define that? It's a typical exam question I have. All right, define this using your language. Okay, so that's what I do. But you don't have to memorize. Okay, you understand the concept, and then you just look up and then synthesize and then write down. So that's what I want you to do. So memorization is not my priority. Although there are a few things you need to memorize, but it's not too much. yeah, so the students will be able to understand specific plant physiology under a controlled environment, and then students will gain understanding of basic of energy and mass transfer. That sounds like super engineering, right? So that's one thing I introduce in this course. So so I would say this is unusual plant physiology course. But it's very important to know the factors affecting, for example, leaf temperature. Without understanding that, you probably don't understand what is the factors affecting your plants. But anyway, so that's you're going to go through. And then the important concept you want to develop is a plant-environment interactions. Okay, how plants are affected by environments, and then also how plants affect the surrounding environment in a growing system. So that's the interactions. Very important in a semi-closed environment in the greenhouse, growth chamber, vertical farming, tissue culture, all that, all right? And then you would understand additional level plant-environment system interactions, all right? So that's the goal. At the end of this course, you have a whole idea, you know, the 3 layers, plant-environment system interactions. So that's what you get there. And then graduate students will have a better understanding of current status of controlled environment agriculture research, plant science engineering research, doing a review, you know, research review. And undergraduate students have opportunity to listen to their presentations at the end, you know, what they found, and then come up with a unique idea. So that's what we are doing. So I emphasize quantitative understanding. Try to understand using numbers, using equations, and why it's so powerful way to find a solution to a problem. Quantitative understanding. Declined, but how much decline? Is that linear decline or exponential decline? So that's very important. And then that would give us opportunity to develop new method or technology. Okay. And many other, you know, good things coming out from quantitative understanding. So that's what I try to do in this course. Yeah, and then also I talk about measurement and monitoring technique of the controlled environment. Not much, because there are courses like that in our group if you want to know more. But I'm going to sort of review the important point of the measurement, monitoring, and some controlling techniques in controlled environment research, and then also production. And why? Because of the, you know, if you are not properly understanding what's going on in your climate, in the environment, you are not going to be able to find a solution to the problem. You know, quantitative understanding, you need a value. Is it under the temperature of 15 degrees C, or is it the issue was specific to that temperature, or it is all over? So that, you know, to do the quantitative understanding, you need to quantify what you have as an environment and conditions. So that's what I cover. So if you finish writing, you can just submit here, and then you can go and enjoy your day, rest of your day. Thank you so much.
Thank you.
All right. So see you next week.